Okay, so we were looking, we started this topic in the previous class. And this topic we are on sets. Now, over the years, CSEC has somewhat downsized sets in terms of the exam. Now, there was a time when it used to appear on paper 2. I'm not seeing much of it on paper 2 anymore. However, you will see questions appearing in the multiple choice paper. And so we still will have to go through this topic and understand some of the concepts, what they usually require in previous years. We won't be going into that depth. They usually have up to 3 sets overlapping. In recent years, they only have 2 sets overlapping. So as much as possible, I'll go into as much as you will need to know to cover what is on the syllabus. All right, so as would have mentioned, Miss Cold Spring is fairly new, so she will take a little time to catch up with us. Miss Cold Spring, have you done CSEC maths before?
Yes.
Okay. Will you be, how long ago would you have done it?
2020.
Okay, that means you will be doing SBA this year again.
Yes.
Okay. All right, so just to recap, I'm just going to take this from the top since we haven't gone too far in it. So I'm just going to kind of briefly recap what we would have done so far. So we started off with the topic sets. We say that by definition, a set is a well-defined collection of objects or things. By well-defined, we mean that we should be able to identify easily the members that belong into a set. We shouldn't have any doubts of what the members are, like the set of objects in a female handbag. It shouldn't be doubtful as to what the members are. So there are certain elements that we wouldn't really expect to find in a female handbag. So those would not be a member of a female handbag or not an element of a female handbag. So we can tell what belongs to a set without ambiguity. And just to break that down without confusion. Now, set notation, the big word notation here simply means symbol. So set notation, you can read it as set symbols. And so these are some symbols that we will be encountering in this topic. So it makes sense noting these symbols. All right, so we would have gone through these symbols from previous class and note that each of these symbols have their specific definition or meaning. And so I would advise you to learn these meanings so that whenever you see these symbols used, you know exactly what they mean, you are able to interpret them. So the curly brackets are the braces, means a set off. When you have a brackets with a common N outside and a capital A inside, now the letter inside denotes the name of a set. So here we have capital A, so this is the set A. The N outside denotes the number of elements in the set A, right? So inside the brackets, A tell you the set, N outside tell you that you need to find the number of elements or the number of members in the set A, and you do so by simply just counting them. Now here, the third notation that we looked at, it still has the braces, meaning that we have to read it with the meaning of the braces, which is the set of. So we start off by saying the set of, and here we have X represent elements. So the set of elements X, this colon means such that. So whenever you see this symbol, you read it in the same way. So the set of elements X, such that. I hope everybody is following me so far. Now this fancy looking kind of E, not really a E, but is a symbol, means that is an element of or is a member of. When you have some element of a set, this symbol is placed between that member and the set. This symbol here denotes not an element of or not a member of. By simply drawing that stroke right down it, that stroke means not. So whenever you see any kind of operation with a slash down it, the slash simply means not. All right, so here now we have this fancy looking E or this fancy looking U. These are more of the, what I would consider the classical way, meaning that the a little bit more the historical way by which they would denote the symbol for the universal set. Now, in recent time, these symbols have transformed to something more simpler. Just a common U or a capital U, as you know, U would denote the universal set. So these fancy symbols, you probably won't see them used much more. It's just a pretty much U, but just to note that these symbols denote universal set. Now here we have this symbol here, which is a Greek letter known as phi. Now it is not exactly the way how it looks here. How it's supposed to look, it should have a slash all the way down the middle like that, with a little cross at the top and the bottom. And that's how it really looks. But for the purpose of, trying to represent this, we use this symbol that seems pretty much close to this one. So when you see this symbol, which is the phi, it represents empty or null set. So that indicates when you have a set which has no member at all in it. All right, now this fancy looking U, really not a U, but you can think of it as a U, represents union, and that has to do with when you're united more than you're uniting two or more sets together. Then we use that symbol to denote that we are collectively uniting the sets. This symbol looking like an N, it is the symbol representing intersection, and an intersection with two sets would be the region where both sets overlap, where they have common elements, and that area is denoted by this symbol known as the intersection. And when it is used between sets, it is therefore telling you that you should look for the common elements in the sets that they are between, or it is between. Now this sideways looking N also is another symbol used to denote a subset of. So just in a similar way like how the union and the intersection is used, it is used between members and the set itself. So you will see more of how these symbols are used as we move along. Now this A with a dash, now for set notation, set symbol, this A with a dash means complement of a set. And a complement of a set is simply the members outside the set. So the complement of set A would be all the elements outside set A. Now, A by itself, when you see A by itself without the dash, it means you have all the members inside set A. You're focusing on those members inside A. Now, why this is called complement, if you notice it's spelled with an E, is that the complement of set A together with A completes the universal set. So all the members outside of A together with the members inside of A completes the universal set. So hence the reason we call outside A complement. All right. So another name often used for A complement is A prime. So if you see A prime or A complement, it means the same thing. So you should look out for the different uses in these words for the symbols. All right, Z represents integers. And so in math, whenever you see a Z, the symbol, it represents a set of all integers. And by now, most of my students would know that integers consist of positive and negative numbers as well as zero. All right, now to denote all positive integers, they put a plus sign behind, which is the plus sign just denoting that you're just dealing only with the positive integers. And likewise, if they use a minus sign, it would denote that you're dealing with only negative integers. All right, Q is the symbol that is used for rational. And we say that rational are fractional numbers, anything that can be expressed, any number that can be expressed with a numerator and a denominator, those are called rational numbers. And we use the letter Q to represent that set. So here, Z represents the set of all integers, Q represent the set of all rationals. All right, so we had said that some sets have special names. And so we look at the example, a pack of cards, a fleet of ships, a pride of lion, and somebody would have given an example like a school of fish. And so these have special name based on the members that they're dealing with, all right? Now we say that the things belonging to a set are known as members or elements of the set. The element of a set may be specified in two ways. One, you may list the elements, and in listing, you always use curly brackets to enclose the members that you're listing. So remember now the curly brackets there, it means the set of. So in this case, you would have the set of 2, 4, 6, 8, 10. So that's listing the members. Now, likewise, you could be listing the set of vowels. So this would be the set of A, E, I, O, U. Now, note that when you are listing the members, when you're specifying a set by listing the members, you're actually writing the members, separate them with a comma, all right? Now, we have another way that we can specify setting is by description. So description simply means you describe what the sets are. So here we can describe a set by saying the set of even numbers between 1 and 11. So in this case, you would know exactly what members belonging to this set. And so you may get a set by description, but you must also be able to list the members that are described. So in this case, if we are to list the members that are described, these would be the members from, so it's between 1 and 11. So this would be 2, 3, 4, 5, 6, 7, 8, 9, 10. So those would be the members. If you are to list them, you would list those in curly brackets. Now here, let me correct this. This says the set of even numbers. So it means that you would only consider the even number, which is 2, 4, 6, 8, 10. And those would be between 1 and 11. So this is a description of the previous set that was listed. So if you notice, we have 2, 4, 6, 8, 10. So this is the listing, and this is the description. Now we could also say this, the set of even numbers from 2 to 10. So when we're describing it, not only that we can describe by saying between, but we can also say from. So we could say from 2 to 10, and that would be perfectly fine in our description. And for the second set that we would have listed would be the vowels. So we can describe it by saying the vowels in the alphabet. All right, so the curly brackets, don't forget the curly brackets mean the set of, so the set of vowels in the alphabet. All right, here, this is where we had stopped last class. And so this is another type of description, and this is description by set builder's notation. Now, set builder's notation, here we see the word notation again, which means symbol. Now, set builder's notation or set builder's symbol, meaning that when we are describing a set in this way, we're using symbols to describe it. So example here, we would see E equal the set of, remember how we read this now. So here we have the X followed by the colon. So we say the set of elements X, and the colon means such that, and here you would have now the symbol X is less than 10, and you have a comma to denote that you are given that description. And then now another description is that X would be members of whole numbers. So clearly this set is described as a set where X is less than 10, and X also has to be in the set of whole numbers. Any question at all? Raise your hand, and let us continue from here. So I just give a brief review of what we would have gone through from previous class. So now, does anyone remember how we can now list the elements from this set? Ms. Wilson, would you like to start us off by listing the members or the elements of set E?
Of set E, sir?
Yes.
All right, so that would be from 0 to 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9.
All right, so while you're giving me the members, I would like for you to just give me the reason why you chose these members. All right. So you
All right, sir. So the set notation is saying that the set of the set of elements X such that X is less than 10. Hold on, sir. Set is X is less than 10, or X is an element of whole number. So it's a member, sorry. It can be either an element or a member of whole number, right? So the numbers inside here would have been whole numbers from 0 to 9, less than 10.
Okay. All right. So based on whole numbers, we know that whole numbers are numbers starting from 0, including the counting numbers. And so from 0, 1, 2, 3, 4, 5, 6 onwards, those are referred to as whole numbers. And I want you to pay special attention that we don't call negative numbers whole numbers, because by definition, they are not. However, sometimes we may describe them as negative whole numbers, but in terms of definition, that would be incorrect. But if you do refer to them in that way, you should understand that they're really not whole numbers. All right, so for the set Miller's notation, these are commonly used when we are dealing with exam. So rather than the description by using words, you may see description using the set Miller's notation. So it is very important that you spend time learning how to read these descriptions, because not only will you be required to read them, but reading them, you should be able to list them. And so to be able to list them, you have to be able to read them. So that is something that you shouldn't overlook. So whenever you see these symbols, you try to spend some time and try to read them and list the members. Is that clear, guys? Let me see the hands if you are following clear. All right.
Sir, can you go again, sir, please?
So where did I lose a Miss Green?
This is the last part, sir.
Oh, so I was, you mean what I was saying about the reading of them, or just to go back to and read it for you? What you want me to do?
The reading of them, sir.
Oh, you want me to say why it is important to read them? That's what you're asking me, Miss Green?
Yes, sir.
So most times when you're in a question, you will find that they will have follow-up question. By giving you this, they may ask you to list the members. And to list the members mean that you have to know what the range of values are. So based on this description, this is a set of elements X. Now, X, as we know, would have been an unknown, but by the description, it tells you what the range of values for X ought to be. So X has to be numbers less than 10. So we know that X would have to fall within any range less than 10. But then again, they have another part of the description here that X must also be whole numbers. So it means that if they tell you that X is whole numbers, even though you have -1, which is less than 10, you would not include -1 because -1 is not a whole number. So you have to pay attention to these little subtlety in the details. Is that clear to you now, Ms. Green?
Yes, sir.
And so based on the description, then if the X values are whole numbers less than 10, then we know whole numbers begin at 0. So in our listing, we simply list all the members from 0 up to, how far are we going, Ms. Green? From 0 to how much?
9, sir.
Right, from 0 to 9, because it has to be less than 10. So we go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And we put those in curly brackets when we are listing them, and we separate them by a comma. All right, is that clear now to everybody? Let me see your hands. All right, so moving along. So this is pretty much what it would have read based on what I have just explained. So this means it means that E is a set of numbers X such that X is less than 10, and X is a member of the set of whole numbers. So that's what it read. Now, having read it, then you should be able to list the members. All right, moving along. Naming sets. In naming sets, we generally use capital letters to name the set. As you note in the previous description here, we use E, but we use a capital letter E. So this letter E here is the name of the set. All right, so naming set. When a set is to be used more than once, a capital letter is used to denote it. All right, so in other words, we name the set using capital letters. Example, A, which is a capital letter, would be the set 1, 3, 5, 7, 9, 11. Now, we're going to jump into our first bit of exercise for sets. So we're going to go through these orally. So here for the first exercise, you are to write down the members of the following set. So in other words, you are to list them. So for question 1, you have A is a set of odd numbers from 5 to 15 inclusively. So if you are to write those members down or list them, let me ask Ms. Scott, what are the members of A based on the description? Ms. Scott, are you there? I hope you are hearing me. I'm not hearing any response from Ms. Scott. Ms. Green, would you like to list those members for us? A equal to the set of odd numbers from 5 to 15 inclusively. Ms. Green, are you hearing me? You can acknowledge me in a student, whether you can do it or you can't. You just, if you don't know what to do, you just say it. Are you hearing me, Ms. Green? All right, Ms. Clark. Ms. Clark.
Yes, sir.
Yes, sir. I'm
Hold on a second. Ms. Green, were you hearing me just now? I think what is happening with Ms. Green is our internet connection is poor. All right, Miss Clark, go ahead and tell me the members.
The members I think will be 5, 7, 9, 11, 13, and 15.
All right. So thanks very much, Miss Clark. So the word inclusive there means that you have to include the 5 and the 15 in the list of members. All right. Let me find out who else I can call on now. Mr. Giovanni, are you hearing me?
Yes, sir.
All right. Just checking. Well, Miss Cold Spring, Miss Cold Spring, are you hearing me?
Yes, I'm hearing you.
All right, so the second question is yours. Pretty much easy and straightforward. X is the days of the week beginning T. What are they?
Tuesday and Thursday.
Tuesday and Thursday. Thanks much. Even numbers, question 3, even numbers less than 12 Mr. Giovanni, even numbers
Yes,
less,
sir.
even numbers less than 12. That's question 3. That's yours.
Okay.
Excuse me, sir. When he's finished, can I do P number 4?
Okay, all right, then Miss Shay, I'll allow you to do PR question 4. Mr. Giovanni, I'm not hearing you.
Okay. So I said 2, 4, 6, 8, 10.
Okay, even numbers less than 12. All right, so 2, 4, 6, 8, 10. All right, that is acceptable. All right, Miss Shay, your turn now.
Sir, 2, 3, 5, 7, 11, 13, 17, 19, and 23.
Very good. Thanks very much, Miss Shay.
You're welcome.
I hope everybody are able to tell the difference between prime numbers and other numbers that we would have called. We have another name for the ones that are not prime. I can't, it's not coming to my memory right now. But for prime number, can anybody remind us of the definition of a prime number? Let me call on someone. All right, Miss, I haven't seen in a while, Miss Trabia. Give me the definition for prime numbers, Miss Trabia. Miss Trabia, are you hearing me? Miss Trabia, can you indicate to us whether or not you hear me? I'm not sure why Miss Trabia is not responding. Anyway, Mr. Paisley, are you hearing me?
Yes, sir.
All right, can you just give us a definition for prime numbers, please?
Numbers that only one and itself can go into without leaving a remainder.
Yes, thanks very much. So by definition, a prime number is a number that has only one on itself as a factor, meaning only one on itself can divide it without a remainder. Exactly. All right, so I hope by now everybody knows that 1 is not a prime number. And what the reason why 1 is not a prime number is that 1 only has itself. And so by definition, a prime number is a number that has 1 on itself. So by definition, 1 wouldn't fit that definition because 1 only has itself, which is only one factor. But by definition, a prime number has 2 factors. It has 1 and it has itself. All right.